Alrighty, let's talk a little bit about charges and static electricity. Something that you guys are familiar with is that shock that you feel when the air gets real dry and you either slide out of your car and touch your car or drag your feet across the carpet and touch a doorknob. That's all static electricity. And it starts off with the idea of electric charge. And charge is the property of an object that causes some sort of electrical force. It's surrounded by an electrical field. We have positive charges, which are generally protons, and negative charges, which are electrons. And you'll probably remember from elementary school that like charges repel each other and opposites attract. Here's a little bit more about charge. Charge is something that we call quantized. So there's no such thing as a half charge. There's not a half electron. There's not a half proton. Well, there are subatomic particles. We're going to talk about a full charge. So when an ion has a charge of +1 or -2, that is a full charge. But we also have something that's called a coulomb, and that's the unit of charge. And it can get a little confusing because I just said they're whole charges, and now I'm going to tell you that one electron has a charge of -1.6 times 10 to the -19 coulombs. So if you're measuring the charge in coulombs, it's going to be that 1.6 times 10 to the -19. If you're measuring it in just charges, number of electrons, number of protons, it's +1, -2, things like that. And the proton has the exact same magnitude of charge, only it's positive. So if you picture an atom, the electrons orbit the nucleus, and they are freer to move from one atom to another. So it's the electrons that move. It's not the protons. The protons are bound tightly into the nucleus. So if you gain electrons, then you're going to have more electrons than protons, and you end up with a negative ion. And if you lose electrons, you end up with more protons than electrons, and you have a positive ion. And to kind of carry that a little bit further, we have the idea of net charge. And net charge is the sum of all of those extra charges in a system. So you add them all up. And if we just consider the system that we have here, a tiny little atom, this atom has 5 electrons and 7 protons. And if we want to find the net charge, we just add them up. -5 plus a +7, and we end up with a +2. So that is our quantized amount of charge, +2. We have 2 more protons than electrons. But if we want to find the net charge in coulombs, we take that number and multiply it by the charge on a proton. Since it's positive, we use charge on a proton, and we end up with 3.2 times 10 to the -19 coulombs. So depending on what you're using it for, you may talk about it in the whole numbers, or you may talk about it in coulombs. So we're talking about charges, we need to talk about the charges moving around in the materials. And so we have conductors, insulators, and semiconductors. And conductors are the ones that those electrons are more free to move around in, and they flow easily, and those are metals, basically. And insulators are the ones where those electrons are tightly bound to the atom, and they're not free to move around from atom to atom. So current doesn't flow, charge doesn't flow, and so that's going to be rubber, glass, styrofoam, some of the other things that you think of as insulators. And we have semiconductors, and they're kind of halfway in between, and they actually start off as something that's a good insulator. But when you put impurities in it, or if you add some energy to it, it switches over and can conduct electricity. Some common ones are silicon and germanium. So now we talked a little bit about charges. Let's talk a little bit more about charges moving. And there's a couple different ways to transfer charges. And we're not talking about electric circuits. We're just talking about charges moving around. And one of them is by contact. You can transfer charges from one thing to another either by just touching the 2 items together or by dragging 2 things across from each other. So you rub your shoes across a carpet, you pick up charge. The transfer will stop if these things are in contact when the electrons reach equilibrium. The other piece would be by friction. You can actually drag off some extra charge, and they rub off from one surface to another. One of the other ways is by induction, and when you put a charged object close to another object, it causes that object's charges to rearrange, and they move towards the surface, causing a polarization. So if you bring a negatively charged object close to a neutral object, all those positive charges will move towards that negative object you have, and all the negative ones will be pushed away. That's kind of the basics behind charges and transferring charges. And just remember, next time you're dragging your feet across the floor, you touch that doorknob and you feel a little spark. Now you kind of know the physics behind it. Alrighty, bye-bye.